Assalamu alaikum wa rahmatullah. This is Muhammad Kamal Hussain, content creator, Triangular Kamal Academy. Here we are going to discuss one of the most important topics for the students of Standard 9 and 10, which is Trigonometry, Chapter 8. Here three exercises including the Chapter 8, 8.1, 8.2 and 8.3. Inshallah, step by step we will discuss full chapter here. Let's see the topics today. Class 9-10 Higher Mathematics, Trigonometry, Chapter 8, and the content related with exercise 8.1. The first we are going to discuss here the concept of axis and the quadrants. So I think all of you know about the axis here. X or x prime, this horizontal line is the short list called the x-axis, and this vertical line y, origin is O, and y prime, the short form is called the y-axis. When we draw two mutually perpendicular line, there are total 4 equal parts. This is called the first quadrant. This is called first quadrant. That means 1/4 of the total part. This is called the second quadrant, and this one is the third quadrant, and this one is called the fourth quadrant. So in this quadrant system, like if we see the first quadrant here, the positive side of x and positive side of y, that means when we consider here like 2 points 2 and 3, here abscissa is positive 2, ordinate is positive 3, that means 2 unit right side and 3 unit upper side, that means all are positive here. In the second quadrant, this is the negative side of x, that means ordinate abscissa must be negative, and it's also the upper side, that means positive side of y, so it's 1 unit positive. So in the second quadrant, that's why y is positive and x is negative here in the second quadrant. So first quadrant, both are abscissa and ordinate, both are positive. Now see the next and third quadrant. Here third quadrant, x is negative and the left side, and here y is the below downwards, so it's also negative. So both positive, x and y both are negative here. So in the fourth quadrant, the right side of x positive and the downward of the y is negative. So now first quadrant, second quadrant, third quadrant, fourth quadrant successively, the fourth quadrant done. So if we see here, this one will be the anti-clockwise, like first quadrant, then second quadrant, then third quadrant, then fourth quadrant. So it started and counting like anti-clockwise, first, second, third, fourth. So now basically if we asked you here like draw 45-degree angle, 45-degree angle, then in the quadrant system, the 45-degree angle, we have to start counting from the positive of x direction, like this is y and this is y prime. So if we start the counting, like this is the 45-degree angle. So in the first quadrant, that means 45-degree angle lie on the first quadrant. So if someone asks you to draw 120-degree angle, now 120-degree angle, so this is up to 90 and 90 plus something. So in the second quadrant, there will be 120-degree. So 120-degree lies on the second quadrant. In the same way, if we draw the figure of 250 degree, that means 250 degree, 90, then 180 and 250, just 20 degree less than the 270, so it will be in the third. This is total 250 degrees, so now it's in the third quadrant. In the same way, just we can draw like if we draw 400 degree, now it one will be first 90, second 90, 180, 390, 270 and 490, 360. So 360 plus 40 is again repeating here in the first quadrant. So now total this angle started from the positive direction of x-axis and completing the whole round, it came again in the first quadrant. So now this is in the this angle 400-degree lie on the first quadrant. In the same way, if we call you identify the position of the 800 degrees successively, we have to rotate here. And it's easiest way, you have to divide by the 90, then you will get here 7 point, this is 8 point something. 8 point something means 9 step. So first, second, third, fourth, fifth, sixth, seven, eight, nine. So in the first quadrant, 800 degree will lie in the first quadrant. This is all the positive angle, always count in the anti-clockwise. So now, if we count here the like minus 65 degree. So minus 65 degree is the negative angle. Negative angle always count the clockwise. Suppose this is the positive x, this is negative x, this is positive y, and this one is the negative y, and the origin is 0. So minus 65 degree always count in the clockwise. It started from x, and so now it's the leftward. We have to draw here. This is the minus 65 degree. So that means in the fourth quadrant is the minus 65 degree. In the same way, if we draw here another angle like 240 degree, minus 240 degree. So now this is the positive x, positive y, and the negative y. Started from the origin x is positive of the x-axis. So it's now negative angle. That means it will be the clockwise. So first 90 done, and 180 done, and 270 done, 200, this is not 270, so 180, 180 plus 180 plus 60, that means in this quadrant this one will be. So here total this angle, now this angle is minus 200 minus 240 done. So now this is the fourth quadrant, and then this one is the third quadrant, and this is the second quadrant, this one is the first quadrant. So minus 240 lie in the second quadrant. In the same way, we can identify the position of minus 500 degree or plus 500 degree or minus 700 degree or plus 700 degree. In the same way, we can identify any types of angle in the quadrant system. If the angle is greater than minus 360 or less than greater than plus 360 and less than minus 360, it one will be repeating case again. So now this is the here in our academic book, here basically we discuss two types of angle. The degree system, including in the step in the sexagesimal system, and another method is called the circular system, or the unit of the circular system is called the radian, and sexagesimal system is the unit, is the greater unit is degree, and the smallest form of the degree is called the minute, and then smallest form of the minute is called the second. So in the sexagesimal system, there are three consecutive angles. So degree is the greater one, then one step smaller than degree is called the minute, and minute to then second. In the circular system, it's always right here in the full form radian, or it's called the radian angle, or simply we can use here the symbol here is the C, is the radian angle. So now let's see here what is actually sexagesimal system. In the sexagesimal system was an ancient system of the counting, calculations, and numerical notation that used power of the 60, much as the decimal system used the power of 10. And rudiments of the ancient system survived the vestigial form of our division of the hour into 60 minutes and the minutes into the 60 seconds. Actually, if we discuss this sexagesimal system, it one will be clear to you if we discuss including the angle here. Okay, let's see here. This is 180 degree. We all know this angle created inside the figure is 180 degree. This is 90 degree. This is 45 degree. So now this 90 degree divide into the 90 smallest form. Which each portion is called the 1 degree. Okay, now if we think here the figure like this, suppose this is the 90 degree, And this 90-degree angle divided into the 90 equal parts. These all parts individually called 1 degree. There is 1 degree, 1 degree. So now if we think here, this is the 1 degree. This is this one part from the hair. Just take any one part from the hair, and this is the 1 degree. So now if we divide again this 1 degree, if we divide again this 1 degree, 1 degree, 1 degree by 60, 1 degree by 60, we will get here these portions. Basically these portions will be 1 minute. So standard form of the length of 1 minute. 1 degree, the 1 degree is divided, the length of 1 degree or the measures of 1 degree is divided by 60 equal part. Then each part length is called the standard form of the 1 minute. Again, 1 minute is divided by 60. Then this form will be the 1 second. This is standard form of the second. That's why angle and time both are connected to each other. So the measures of 1 degree is divided equally 60 smallest portion, 60 smallest portion. Then each portion is called the 1 minute. And then 1 minute again divided into, like this is the gap of the 1 minute. Then 1 minute divided into the 60 equal portion. Each portion is called the 1 second. That's why this is the relation in between angle with the time. So now we can see here 60, this is the symbol of the second and this is the symbol of the minute. If we write here 60 second, this one will be 60 second is equals to 1 minute. Again 60 minute, then 60 minutes came from basically together, these 60 minutes together make 1 degree angle. And we all know 90 degree angle means 1 right angle. So these together they are called the angle in the sexagesimal system. So in the sexagesimal system, greater angle is a degree, the second greater angle is minute, then the smallest form is the second. So there are another method counting the angle is called the circular system. Basically circular systems comes from the circle. We will discuss here this one. Circular system or radian measures. The circular system or the radian measures, this is the system. The angle is measured in terms of the radian, where the radian is defined as the angle subtended at the center of the circle by an arc whose length is same as the radius of the circle, and 1 radian angle is denoted by the 1 to the power c, not actually 1c. And noted to 2 right angle is equals to 180 degree, and 180 degrees is called the pi radian. Comparing this one, inshallah briefly we will discuss this one. So let's see the figure to clear the definition here. This is the circle whose radius is r. If you put the pointer at the position here and take the measures, place the pointer here and take the measures of the radius ox and the cut here the axis. That means arc xy is equal to the radius ox, then joint oy. You will get here the angle. This angle is called the radian angle. This is called 1 radian angle. So here in the right side figure, we can see here the red color is equals to the blue color. The radius is equals to the arc. Then subtended angle at the center of the circle is called the 1 radian. That means this is the condition. Arc length must be equal to the radius of the circle. So now we have to know what is the basically relation in between sexagesimal system and the circular system. So here we have to know suppose this is the AOB inside the circle here. ABCD is a circle. Here OB, this is the radius OB, this radius which is equals to the arc PB. This is the radius arc. Here arc PB is equals to the radius r. That means POB angle, this is called the radian angle. And then OA is the perpendicular on OB. The line OA is perpendicular on OB. That's why AOB angle will be 90-degree angle. So now we will find the value of angle POB. That means we have to find the value of angle POB. If the value of angle is constant, definitely radian angle will be constant. If this is not the constant, definitely we will get its different value in different figure. Okay, let's see here. Suppose in the circle ABC, O is the center, POB. Actually, this one will be the POB angle is a radian angle. And we have to prove POB angle is a constant angle. That means, inshallah, step by step, we will prove POB angle. This one is constant angle. Now, OA is the perpendicular on line segment OB, radius. Okay. The first step here, see, OA intersect the circumference at the A. That means the arc AB is the 1/4 of the circumference. Basically, if we clear this one, I think it will be better to discuss if we draw the figure again here. Now, this circle is divided into the 4 equal parts. Here, this is the one part, this is one part, this is 1/4, there is 1/4, there is 1/4. The 1/4 is A, this A, this is B, this is C, this is D. So here arc AB is equals to arc BC is equals to arc CD is equals to arc DA. So there. Now total the 4 arc together make a circle A2, A2B, B2C, C2D and D2A. And together they make the round of the whole circle. This is called the circumference of the circle. We all know circumference of the circle is 2 pi r. This is the total boundary side of the circle. This is the 2 pi r. And AB is the total 1/4. AB is the 1/4. That means 1/4 part of the whole circle. So arc AB will be circumference divided by 4. That means it's 1/4 part of the whole circle. So after doing the calculation, we will get here pi r by 2. So now, if we think here, arc AB is equals to pi r by 2. This is the total 1/4 part of the whole circle. So here, that's why now arc AB is the 1/4 of the circumference. That means is the pi r divided by 2. From the definition of radian angle, arc PB is equals to the radius r, because this one is equals to radius r according to the definition of radian angle. That's why arc PB is equals to r. Now, from the corollary, definitely we know subtended angle is completely dependent on the arc of the circle. Inshallah. Okay, now see this one. Suppose this is the circle here, and just take the any arc, and now find is the subtended angle. This is the subtended angle of the arc PB. If we take the arc is greater than PB, like this one, suppose this is AB, then take the subtended angle. So which angle is greater? If the arc is greater, then its subtended angle is greater than the smaller subtended angle by the smaller arc. Suppose this is 70 degree and this is 45 degree. If we take this is the smallest arc, and then subtended angle will be the smallest. This is the smallest. So definitely subtended angle completely dependent on the arc. If arc is greater, subtended angle must be greater. If arc is smaller, then subtended angle must be smaller. So now that means the relation between subtended angle and arc is directly proportional. If arc is increased, then subtended angle must be increased. If arc is reduced, then subtended angle will be reduced. So here now see PO, this is the corollary 3. Basically, in your academic book, subtended angle directly proportional with the arc of the or arc is completely dependent, or arc is directly proportional with the subtended angle. So this is the corollary 3. Yeah, here we can write. Okay. So now POB and its arc PB, AOB and its arc AB. If we draw the cross multiplication here, what will be result? Do the cross multiply like x by a is equals to 2 by 3. If we do the cross multiply, there will be x multiply with the 3. That means 3 times of x is equals to 2 times of a. In the same way, if we do the cross multiply here, PB, POB angle with the arc AB and AOB with the arc PB. So now right here, POB angle is multiplied with arc AB and arc PB is multiplied with the angle AOB, doing the cross multiply from the fractions. So now if we find now value of the radian angle here, we will get POB angle, and this is the equal. First write here the right side arc PB and multiply AOB angle, and this is multiply with POB. So now if we shift this one from the left side to right side, this one will be divide. So there is arc AB. So now this is the value of the radian angle, radian angle value. Arc PB multiplied with the AOB divided by AB. Now put their value. Arc PB, the PB arc, its value is R. Its value is R here. The value of the PB arc is value is R. The arc AB, its value is pi r by 2. Already we have done this one here. We have done this graph here. The arc AB is equals to pi r by 2. And now value of AOB angle. Okay, see the here value of AOB angle. Value of AOB angle from the figure we see here. AOB angle is the 90-degree angle here. So put the value. This one is 90-degree angle. That means one right angle. So now if we do the calculation here, we will get first right here the R. This is the divide here. This divide converted into the multiply. Then this denominator fraction like pi r by 2 will be changed. Numerator will be denominator. Denominator will be numerator. This is pi r, like a by b divided by c by d. If we write here a by b, then divided converted into the multiply, this one will be d by c, and the denominator fractions will be changed, and numerator will be denominator, denominator will be numerator. So in the same way, pi r here numerator is now denominator, and 2 is denominator here, it changes to the numerator, pi divided by the pi. So finally we will get here 2 by pi, and 2 by pi, and the right side is the right angle. Unit is right angle. So now here finally we get value of the radian angle is 2 right angle divided by pi. So here if we see the calculation, right angle is a constant, is 90 degree, and pi is also the constant. If we divide one constant by another constant number, definitely our final result will be constant. If we add one constant number with another constant number, the result will be constant. If we divide one constant number by the another constant number, also one result will be the constant. So here 2 pi right angle all are constant. That means their calculation must be constant. That's why we can see the value of POB is the radian angle, which is the constant angle. And this is the theorems, and class 9-10 standard student in the exam, board exam, you have to write these theorems that prove that radian angle is a constant angle. This is the 4 marks question here. So now here we see POB angle. POB angle is equals to the radian angle, and whose value is 2 right angle divided by pi. So this is POB means 1 radian angle. So simply we can write here 1 to C. Red symbol of the radian angle is C. So two right angle means 180 divided by pi, and this is the degree system. So this is the relation in between circular angle and the sexagesimal angle. So 1 radian equal to 180 by pi. So here in this content we will apply these theorems. 1 radian is equals to 180 divided by pi degree. So in the same way, if we find the 1 degree, this one will be the changed. This one will be now pi by 180 radian, or you can write here C. So this is the relation in between circular angle and the sexagesimal system angle. The relation between radian to degree and degree to radian. So now here another theorems given here. Inshallah. Okay, let's see the one question first. Suppose there are given here 45 degree and the requirement is convert this angle into the radian. So now we know 1 degree is equals to pi by 180 radian. So 45 degree will be, 45 multiply pi by 180, and this is the radian. So after doing the calculation of 45 degree, this is will be divided by this one, you will get the 4. So this is now pi by 4 radian, or this one will be answer. If you put the value of pi, there will be, you can convert this fraction into the decimal form. Like we can use here the value of pi 3.1416, the 4 decimal place divided by 4. Suppose this is the radian. So now divided by value of pi 3.1416 divided by divided by 4, not by 3. Here divided by 4. The result is 0.7854 radian. So also you can give this answer in the decimal form. In the same way, we can convert radian angle into the degree system. Suppose this is now again another example if we see here. So now like convert 0.7854 radian into degree. What will be result here if we convert this one? So now first right, we know 1 radian is equals to 180. Already we have proved this theorem at the degree. So 0.7854 radian is equals to 180 divided by pi multiply 0.7854. This is now degree. Put the value of pi 3.1416 multiply with the 180 and 0.7854, and together this one is the degree. So using calculator, after doing result, this is at the divided by 3.1416, and finally you will get here calculator. This is 45 degree. This is 45 degrees. So now in the both case we can prove this one. If we convert 45 degree into the radian, we will get here 0.7854 radian. If we convert this the same radian angle into the degree, we will get here the 45 degree. So in the same way, we can convert one angle to another angle. Inshallah, step by step, we will do all maths from our exercise 8.1. So now I think this concept is very clear to all of you about the radian angle and the angle of the sexagesimal systems and the minute, degree, and second. So let's see. Suppose there, if we see here another example. Okay, let's clear here another example. Like 45 degree, 50 minute and 35 second. Convert it into, this angle is given the degree, so now convert into the radian. What will be result here? Okay, first step, first write the here like 45 degree, separate this smallest from 50 minutes plus 35 second. Now we know the relation between degree to radian, so that's why we have to convert this minute and second into the degree, because we know the relation between degree to radian, not minute to radian. So first step, we have to convert here all angle into the degree, then we will convert degree into the radian. So now first step here, 45 degree already given in the degree, so no need to convert this one. And here 50 minute, we have to convert this minute into the degree, smaller one to greater one. That's why we have to divide by 60. Now it's converted into the degree. And here 35, first 35 degree we have to divide by 60, then it one will be second to minute, then minute divided by 60, and finally it one now degree. So in times of minute divided by 160, in times of second we have to divide by 60 multiply 60. So now by using calculator we can write here like 45 plus 50 divided by 60, then plus here 35 divided by 3600. So now by using calculator directly we can write this one 33007 and divided by 720, and this one is now degree. Now we will convert this degree into the radian. So now first we know 1 degree is equals to pi by 180 radian. So now this one will be 33007 divided by 720. This one, if we convert radian, this one will be pi by 180. Now this angle converted into the radian. Now using the value of pi, here we can write 33007, value of pi 3.1416, then divided by 720 multiply 180. So here now by using the calculator, first multiply with 3.1416 and then divided by 180. So now this is the result is 0.800801 with the 4 decimal place. So this is the answer. So if we convert sexagesimal system to the radian, definitely step by step we have to convert first degree, then if there is a minute we have to convert this one into the degree, then second have to convert into the degree. Finally this degree with the relation, finally we have to degree convert into the radian. This is answer. In the same way, inshallah, we will practice a few maths from exercise 8.1. Now see the next part here from your academic book. This is the relation in between arc, radius and angle. So now here arc PB is equals to radius R. That means OB, or you can write here OA or OP. All are the same here. Distance from center to circumference. So here POB angle is 1 radian angle. It's 1 radian angle, and AOB any other angle. AOB here any other angle. We can identify this one as theta C, any other angle with the radian. So now from the figure here, let O is the center and OB are unit, then the radius of the circle ABC. In the angle AOB, which make any arc S, and this is PB is completely equal to R. So now we have to prove here S equal to R theta, and this is AOB any other angle. In the this angle of definitely this angle will be in the radian, not in the sexagesimal system. So now we know the relation between here. We know the subtended angle is directly proportional with the arc. The centered angle or produced angle arc is proportional to the center angle, or center angle is proportional to the arc. So now if we see here, like this is the center, and this is suppose B, and this is B, and this is A. So here AOB angle which make arc AB, and this one, and POB angle which make POB angle which make arc PB. So now both arc and PB, the relation is proportional. That's why if the arc is the upper side, this subtended angle must be in the upper side. If the arc PB is denominator here, so now subtended angle will be placed in the denominator. So this make the relation in the equation. The both here numerator, arc numerator and its subtended angle, arc of the denominator and its subtended angle. Now put the value here AB. Just consider here AB is equals to S and arc PB equal to R. Here AOB any angle in radian, and POB is a 1 radian angle. Now do the cross multiplication in between them. We will get here S equal to R theta. So write S by R is equals to here theta. If we write here S by R is equals to suppose theta by 1. So now do the cross multiplication. S multiply 1, this is S, and R multiply theta, this is S equal to R theta. So this is formula, and here angle is in radian. Angle is in radian. Angle is in radian, and S and R both in the same unit. If S in kilometer, then R will be kilometer. If R is in meter, S must be in meter. They are in the same unit, but theta must be in the radian. So by using this formula, we have to solve so many maths from exercise 8.1. So dear students, I think now up to this one already we have discussed here. First, coordinate system. Second, the angle divided into two smallest from angle, degree, minute, and second. Then this together they are called the sexagesimal system. And negative angle, and positive angle. Then next step 4, radian. A radian angle is a constant angle theorems, and another theorems number 6 S equals to R theta, and convert one angle to another angle. This the number step 7. So already we have done all basic related with exercise 8.1. Inshallah from next class we will start math step by step. And thank you so much. If you have any question, please let me know in the comment section. Inshallah, I will try to answer as far as you demand. Hope to see you all in the next classes. Wish you all the best. Assalamu alaikum wa rahmatullahi wa barakatuh. Don't forget to subscribe. Triangular Kamal.